Hey everyone, this is a follow-up to my previous video where we discussed how you can utilize open source large language models to run GitHub Copilot alternatives and use them as your code helpers. If you haven't seen that video, I would recommend you watch that before seeing this. You can find that video on the top right corner of the screen. In this second part, we will see how we can use Tabby ML on a Windows machine and use it as a GitHub Copilot alternative. Since the video became longer than I anticipated, I am going to skip Code Llama in this one. But like I mentioned in the end, if you still want to see this, please let me know in the comments and I'll do the same. So let's go ahead and dive into the whole process. So let's start by seeing my system specifications. First, let's check my operating system. You can see I have Windows 10 Home. Then, as you can see, I have a Core i5. And if you quickly check my GPU, it's a GTX 1060. So you can see that my system is not very powerful. Great. So now let's start with Tabby. Let me close this. And maybe we go to the GitHub page. Go to the installation. And if you remember, last time we installed it via Homebrew. This time we'll use Docker because that's the easiest way to do it on a Windows machine. So for that, we for sure need Docker installed. But let's click on this link and see how we could run it. So once we have Docker installed, we could simply run it via this command. And if we check the CPU version, it runs directly like this. So if you do not have an NVIDIA card and you want to run the entire Tabby server to serve the large language model, you can use this command. Here, as you can clearly see, it uses just the CPU. But in case you want to use your GPU, you should use this command. Of course, you need Cuda installed in order to run this. And if you're wondering what Cuda is, it's basically a piece of software that helps you to perform general purpose computing via your GPU. So if you want to learn more about Cuda, it's actually pretty straightforward to install. And yeah, so for general computing on graphical processing units or GPUs. So like me, if you have an NVIDIA graphic card, you can use Cuda along with this command in order to use it to serve your large language model. So in order to run Tabby, we first need Docker. So let me open Docker. And I think Docker Desktop is what we could install. And as you can see, I could download it for Windows. So let me download it. Let me click here. And my Docker Desktop is being downloaded. Let me close the unnecessary tabs. And once Docker is downloaded, it's very easy to install. Just double click it. I will literally just press next, next, next and finish.
A few moments later.
And once you have installed it, you might need to restart your computer. Once you reboot it, simply click on the icon, double click it, accept the terms of conditions. I'm going to skip signing in, I'm going to skip this, and my Docker engine will start. Now, of course, I won't dive into what Docker is. That requires a separate video on itself, but you can simply Google it and read all about it. Now I see my Docker desktop is running. I don't have any images or volumes. So let's open and go back to Tabby. And let's click on CPU. And we will use this command to serve starcoder 1 billion using Tabby via Docker and serve it via CPU. So let me quickly copy it. Important thing to note here is that this is, as you can see, it's part of run.sh, meaning this $home is basically your home directory, which doesn't work in Windows. So let me try to edit it. Let me open my Visual Studio Code. And here I'm going to name it. I'll just name a folder, but it can be anything. Let me just name it to temp. And this is because I'll make a temp folder on my drive. So let me open my D drive. And here I have a folder. I'll create a new folder named temp. And now if I go here and run our command, it should work. So let me open my terminal. I would recommend, if you do not have the terminal app, install it. I have installed terminal, and then the default I use it for is PowerShell. I've added some customizations, but if you simply go and run it on PowerShell, it should also work. Let's go to the folder, and you can see we have the temp folder here. So let me go to Tabby or VS Code, copy this command and paste it here. And I didn't copy it. Let me quickly try to do it again. And I'll run it. Now it will take some time to download everything. So let's get back once it's downloaded.
A few moments later.
And I got an error. Let's see what it is. It says it includes an invalid character for local volume. If you intended to pass a host directory, use absolute path. All right. So let's put our absolute path here. So if I do is D drive tabby. So our absolute path would be D drive tabby temp. So let me update it. And of course it should be like this. And I'll run it again. And now it's transferring the model from Hugging Face like it did earlier in the Mac video.
A few moments later.
And now we have the server up and running. Let's quickly check it. So I will do local host and 8080. And I'm serving it. So let's go back to Visual Studio Code and we will install the extension. So extension, and I'll search for Tabby. Here's our extension. I will install it. Let's check the settings like we did earlier. Extension settings, Tabby agent settings, and yeah, we have pretty much everything up and running. Let's go ahead and test if it's working correctly or not. Let me just clear it and save it as, oh, it's trying to save it in Tabby client. All right, no problem. Let me go to the same directory where we have this D drive, Tabby, and I'll just put it here. Let me name it temp.py. Why not? All right. We have Tabby installed. I can switch it off. We don't need WSL, and you can see here Tabby code completion is enabled. Yeah, I don't want to switch it to manual trigger. And now let's test it. So we will do the same thing that we did earlier. Let's see. Add 3 numbers. Okay, it's completing. So def add number. All right, and as you can see, Tabby is working on Windows. Let's quickly run it to make sure our code is running. So x equal to add numbers, and let's see if Tabby, oh yeah, Tabby is auto completing this too. So I'm going to press tab and I will simply print the value of x, and let me run it, and it works completely correctly. Let me try to make it a bit bigger. All right, let's try one more thing, and it's, let me add it, it's multiply to integers, and I don't think you can hear this, but my system is, the fans are going full speed, so it's really loud. And let's see if it works. Multiply, I should write multiply to integers, so multiply, and oh, and here again, if I press tab, I get it. Let's put it y. Actually, if I put it x, it was actually suggesting me. Why not? So I'm gonna press tab, but maybe let me rename it to y. And the performance by far is quite good, but I could hear my fan being really loud. I'm assuming it's because of the processing it's doing, and also this is fast enough because the functions are not too big. I think if we go again into some stronger calculations or multiple line of codes with some a bit complex function to write, then it might be really slow. But I'm not going to do that because we are just running the CPU version. So let me quickly run it. And yeah, 3 and 2 is also 6. So let me make it a bit different. 3 and 3. Save, play, and yeah, 6 and 9. Great. So we successfully tested the CPU version. Now, when you run the when you ran that command that I told you, it actually created an image, and you can see that this is the container that's running. So I'm gonna stop it, and when I will stop it, this Swagger UI server, if I refresh it, it's still not stopping, I guess. Yeah, so now since it's stopped, if I refresh it, you'll see that it's not working. You should see it here in Tabby too. So most completion requests timed out. Okay, cool. So the next thing that we'll do it, let me quickly close this and I'll just remove this because we'll start it again. The next thing we'll do is instead of running it locally via CPU, we will run it using the NVIDIA GPU using Cuda. So in order to do that, let me go back to Tabby and go here. And like it said, we need to have Cuda installed. I think I have Cuda installed, but for the sake of this video, I'll reinstall it and then I will run this command. So let's search for Cuda, NVIDIA Cuda download. Yes, it's Cuda toolkit. And I'm not gonna do this. Operating system Windows, x86-64, and Windows 10. Yeah, I will have the local exe. So I'm going to, oh, that's a huge exe. So I'll simply download and run it. It's downloaded, so let's install it. And now it says that I need to install Visual Studio in order to get the full functionality. So I'm going to do that. Let me click it. And I guess community. I guess so. So let me download this here in Tabby. I'm not sure what I should, but let's check back what's required. So some components could have probably be okay. So let me just install it. Okay. I have no clue. I just used the defaults. I didn't click or uncheck anything. And I'm gonna uncheck start after installation. And the installation is now complete. So I'm gonna close this, go back.
A few moments later.
And it's finished. I'm going to uncheck these two and then press close. It actually opened a GeForce experience. So as soon as I press close, so I have closed it. And now we should have Cuda installed. Let me close these. Let's go to Tabby. And let's copy this. And let's open a new terminal. Let's again go back to our directory. I have the setups here, but let me first change this using Visual Studio Code. And now I'm going to paste it. And we will again replace the home directory to this one. Now I have a feeling that this might create some issues. So let's check our directory, and we have, okay, I didn't use temp. Oh, I did. Anyways, let me make another directory. Let me call it temp1, and I'll simply use it to make sure that this version, the mapping that's being done here is on a different location. So this will be our folder. So you can create any other folder, whichever you like, to map this running of Docker. I'm doing it for the sake that we know that all the data that's being kept on the .tabby directory is different from what we used earlier. So we have everything set. If we check our Visual Studio Code, you can see Tabby is not running. If we check Docker, it's not running. So let me again go here, paste our command and run it. This now will run Tabby using my GPU. And again, just like it did earlier, it's downloading the Cuda 1 billion model. If you have an NVIDIA GPU, I would advise you to use this because it's way faster than the CPU version, but we will see how fast it is once it's downloaded.
A few moments later.
As you can see, Tabby is up and running. It also tells us that it's using the NVIDIA GeForce GTX 1060. So let's see how fast it is and how it works. So I'm here at temp.py again. Let me, oh, it says, oh yeah, now it says Tabby is enabled. Let's try this. Def hash oh, and it's actually pretty fast. I just type and it already is predicting. So let's see, a function that takes a string and returns a string. All right, def. Okay, so it's basically changing it to string to uppercase, which is not what we are looking for. But let's go back and try a function to add 3 numbers together. Okay, and def add score 3. Okay, already, wow. So this is pretty fast. Like I have a really old graphic card, and you could already see that it's predicting, and you can see it already predicted what I want to do, and this is actually even better. All right, let's try and run this. Yeah, and it's amazing. Let's do something complex. So first, let's say multiply 3 numbers together. Awesome. Like I'm really surprised how fast this is. Like it's like I'm thinking and it's doing stuff. And oh yeah, calling the function, see, automatically. And yeah, I'm at this point I did not add anything. It's just predicting and running. Okay, let me change it to maybe 10 so that we have different responses. Yes, 6 and 20. Great. Let's do something more complex, or the one it showed. Binary sort tree. No, I should write something better. We'll do binary sort tree later, but for now let's do get max value from from a list or from an array. Okay, and def get max value from array. No, nothing. Okay. Oh, it is. It took some time, but it gave me a response. So let's try to call the function. So, all right, already. Okay. And let's run this now. Awesome. And you can clearly see it worked. I must say I'm really impressed. So the MacBook, when we ran everything on the MacBook, it was fast, but this is next level. Like, you could feel it that you don't have to wait, and intuitively it's just responding. And my GPU is also being used, but at the same time I don't hear my CPU as much. So the system was actually making a lot of sound when I was using the CPU version of Tabby, but now when I'm using it via GPU, it's making close to no noise at all. And if we go back to our Docker, because we just ran it, you could see, okay, now I have two different containers running. Well, one container is stopped and the other one is running, and it's taking barely 0.03% of the CPU. And that's pretty neat. It's Docker related, but I just want to tell you, if you want to stop it, you can simply click on stop. And of course, if you don't need any other container image, like for instance this one, which we use with the CPU, and if you want to delete it, you can simply delete it using this button. So I'll just delete the previous one, and this is just simple how you use Docker desktop. All right, so that's pretty neat. Let's try to do something a bit difficult. So now let me use the binary tree sorting algorithm. So I'll say implement binary tree sorting algorithm, and def binary tree sort. No, nothing. Okay, let's see if it predicts anything. All right, it predicted something. Let me press tab, and yeah, it's hallucinating because obviously there is no such element. Again, the inference is based on the model. So like we saw in the previous video, which used the M1 MacBook, the output depends on which model you're using, and it's quite similar to what we saw there, although it's way faster than the MacBook, at least in my experience when I use the NVIDIA GPU. So I'm not sure if you could guess from my voice, it was quite mundane till we actually got it working, and it's pretty amazing. I'm really really happy with the results that we have got. Maybe we can use some other model from Tabby instead of StarCoder. So I know it can use other models. So let's see the model registry. Yeah, so just instead of Tabby ML StarCoder, we could use something else, maybe DeepSeek Coder, but I think this video is already quite long, so I'm gonna stop here. And maybe if you want me to create a similar video for Llama Extender or to run this on a Linux machine, I could make part 3 and part 4 also. But in case you want to use any other model, you can simply replace star coder 1b with whatever you want. So here we use star coder 1b. You can just put Tabby ML and maybe star coder 3b or CodeLlama 13b, and this should also work. I hope you enjoyed this video and you are able to use Tabby for your own use cases. Please let me know your thoughts and questions in the comments. Thank you for watching, and I'll see you in the next one.